Hello, everyone, and welcome to the fourth session of our Audio Insights Safe and Sound series. I'm Adom Yusuf, the Senior Manager for Standards and Technology at the Security Industry Association, and I will be your host. Today, we're diving into the topic of audio analytics, and I'm thrilled to welcome our two guests who will lead us through this discussion. Derek Vorst, CEO of Sound Intelligence and Chair of Audio and Intelligent Communications Subcommittee, and Avory Joseph, Customer Experience Product Specialist at Louroe Electronics. To kick things off, I'll turn it over to our panelists to share their opening remarks.
Well, hi everyone. Thanks for joining this call. Very happy that we're in the fourth edition of our podcast series for the Audio and Intelligent Communications Subcommittee. We're really grateful for your attention, and hopefully we can make an impact of really helping our customers and partners with making audio even more important in their security operations.
Hello, and thank you for having me on the podcast. My name is Avory Joseph. Currently, I'm for the past 2 years, I've worked as a customer experience product specialist at Louroe Electronics. My journey into the field began with a strong interest in technology, and security, driven by a desire to enhance how we can leverage, technology and enhance sound safety and situational awareness. I'm really excited to share my insights from experiences in the security industry and how audio analytics can play a pivotal role in enhancing security measures in various environments. Thank you so much for having me.
Thank you, Derek and Avory, for the introduction. To explore this topic further, I've prepared a few questions. My first question is the following. How has the field of audio analytics evolved over recent years, and what key advancements have significantly impacted its application in security?
Yeah, let me talk a little bit about that. I think audio analytics has been around for many, many years. It started in a very basic way, right? Basically, decibel level threshold measuring. So as soon as there was any sound above a certain threshold, you would get a notification saying there was a loud sound. Obviously, there's no way to identify between different sounds, but just is it loud or not? So there was some use for that, but over the years, it's also been seen as kind of nuisance alarm. So the next step in that was to say, okay, well, we're not only looking at the sound level at a certain point, but it needs to be for a certain duration. So the sound needs to be louder than X decibels for Y seconds. So that, of course, already takes or gets rid of a lot of false positives, because that slamming door that's just very short but loud, it's only less than a second. So if you say the sound needs to be above a certain level for 5 seconds, 10 seconds, a minute, you filter it out. But all of that is still very basic. So I'd say in the early 2000s is when we really started doing AI in audio analytics. And what I mean with that is that very smart pattern recognition experts, audio experts started looking at, okay, what are the sound characteristics of different sounds? So how does an aggressive voice sound different from a normal voice? How does glass break sound different from other sounds? And they were kind of making the first algorithms to help a computer recognize those different sounds. Then fast forward, let's say 10 years, you see that now we're turning into the machine learning phase. So now it's not just experts that are kind of figuring out, okay, if there's this much energy in that frequency and that much energy in that frequency for this duration, we have an event. No, it's actually based on a data set. You try to train algorithms, and the computer will figure out what is the differentiating factor. So that's kind of the machine learning, random forest and things like that, a phase of it. Then fast forward another few years, and I would say, we're in 2020 now. Let's say, 2012, 2014 is when we started going more into the neural networks, and more recently into, deep learning. So deep learning, it doesn't mean self-learning. That's something that many people kind of think, but that's not the case. So deep learning means that you use a large data set of sounds that you have, annotated, and basically you know what the ground truth is, right? So people have listened to these sounds and say, okay, yes, this was a dog barking, this was a person screaming, this was a gunshot, this was another sound. Based on that big database of sounds, you tell the computer to figure out what are the differentiating characteristics, and now it's using these multiple layer neural networks to figure this out. So it's getting really complex, and that's where you need the additional processing power. So of course, with the processing power increasing and these algorithms getting more sophisticated, that's kind of how audio analytics has evolved and is at the level where it is now.
Yeah, I couldn't agree with Derek, more. I would say that, the field of audio analytics has seen substantial advancements in machine learning and artificial intelligence, enabling more accurate sound classification and real-time analysis. I think it's become more platform and hardware agnostic. Progression and hardware and software help provide more options to storage larger sound files. Those developments allow security systems to differentiate, the difference between normal background noises and critical sounds, like glass breaking detection, and like Derek said, hearing aggression over a certain dB level. I think that having that capability enhances response times and reduces false alarms in the industry.
Thank you both. For my next question, I'd like to ask if you can discuss how audio analytics has changed or improved security operations in various sectors, such as healthcare, education, retail, and corporate campuses.
Yeah, I would say that audio analytics has transformed security operations by providing real-time situational awareness in those sectors. I would say in healthcare, it helps monitor patient safety by detecting distress sounds. Education, you could say it identifies potential threats, and in retail, it could track customer behavior while enhancing loss prevention. Corporate campuses would benefit from improved emergency response through proactive monitoring and audio cues. Also, I had a real quick graphic that I wanted to share with you guys. Let me share my screen for a moment, if that's okay.
Yeah, go for it.
All right, can you see my screen?
Yep.
Perfect. So, some of the 5 benefits of audio analytics, I would say, would be, like I mentioned, proactive response, cost-effective investment, monitoring efficiency, real-time engagement, and confidentiality. Thank you.
That's great. Yeah, that maybe from my perspective, I think it's all true what Avery says. I think the biggest impact is reduction in response times, right? And actually, it starts with awareness. So we know that without audio analytics, more than 50% of incidents are not reported to security. So being able to kind of have an objective way of alerting security that there is something happening, that is where it starts, right? Being aware of incidents. And then the second part is reducing response times. So we've been able to see that with audio analytics, you're able to reduce response times by 75%, which means, let's say, aggression, right? You can nip it in the bud, right? You can be there before it escalates into a physical incident. And that is irrespective of whether it's healthcare, education, retail, corporate campuses, or any other place. That is kind of the most important. How can you really make better use of your existing equipment and your teams out there is by making them aware so they can respond quicker.
Thank you both for that insight. My final question is, what emerging trends or technologies in audio analytics should we be aware of, and how might they shape the future of security and surveillance?
Yeah, I think obviously this field is improving and improving on the technology side, right? So it's about higher accuracy, so fewer false positives, fewer false negatives. It's about detecting all kinds of other sounds. So obviously the industry started with the decibel level, then it went into the aggression detection, gunshot detection, breaking glass, car alarms. But we will see many more sounds that are being classified from power tools to graffiti spray cans to all kinds of other sounds. And I think the biggest thing that we're still kind of in the early stages of is integrating audio analytics with other sensory data. So integrating audio and video and maybe other sensors to really predict when events are going to happen. Combine that with the generative AI and customer service aspects of it. You could potentially hear, see, and feel that, hey, there's a situation happening here, and we will proactively start playing a message on a speaker, but that speaker is also going to listen and really speak back to how these customers are behaving and how they're responding. So I think that's where there's a lot of exciting improvement that are going to take place the next few years.
Yeah, just honestly piggybacking right off of Derek, I recently came across a Forbes article, and in it talked about the future of sound analytics, and it talked about some emerging trends that included the integration of audio analytics with IoT devices, and so pretty much the Internet of Things, and the advancements in cloud-based processing. And how that would allow for more scalable and efficient solutions. I would say additionally, the use of natural language processing to interpret conversations can lead to preventative measures against incidents. So I think that intelligibility and microphone placement is also very important. These innovations would allow likely the enhancement or the ability to provide proactive security measures rather than reactive responses.
Thank you both for this discussion. Stay tuned for our next Audio Insights Safe and Sound series. Please let us know if you have any questions in the comments below. Thank you.